Now we are discussing bitwise logical operators in the Python. Why these operators are called as bitwise logical operators? Because these operations performance will be done when the numbers are converted to binary. So that's why these operators are called as bitwise logical operators. In C language, we already know the bitwise logical operators: bitwise AND, bitwise OR, bitwise exclusive OR. Now here we are taking bitwise right shift, bitwise left shift, and bitwise complement also. We will perform all these operations. Now I am taking two numbers. Number one, some A is equal to any random numbers we can take. I am taking A is equal to 10, and so I am writing the binary equivalent of 10. So it is 1 0 1 0. And now I am taking B is equal to some 4. So we are writing the binary equivalent of B 0 1 0 0. So this is A and this is B. Now when we perform the bitwise AND operation, for every bit we are performing the AND operation. What is the 0 AND 0 0, 1 AND 0 0, 0 AND 1 0, 1 AND 0 0. So finally the result of bitwise AND operation between A and B should be 0. Yes, this is 0. Now we are performing the bitwise OR operation. If I perform the bitwise OR operation between the A and B, then 0 R 0 0, 1 R 0 1, 0 R 1 1, 1 R 0 1. Now we have performed bitwise. Now we have performed bitwise OR operation A bitwise OR B. So 0 R 0 0, 1 R 0 1, 0 R 1 1, 1 R 0 1. Now this is 2 to the power 1, 2 to the power 2, 2 to the power 3. 8 plus 4 plus 2. Result is 14. Now we are performing some bitwise left shift. Bitwise exclusive OR we will perform. We will take the same numbers. So A is equal to same 1 0 1 0, and B is 4 0 1 0 0. We are performing the exclusive OR between A and B. Exclusive OR 0 and 0 0, 1 0 1, 0 1 1, 1 0 1. So same 14 will be the result if we perform the exclusive OR A exclusive OR B. A exclusive OR B I am performing, the result is 14. Now I want to perform right shift and left shift. First I am performing the left shift. This is A. When I perform the left shift to A by 2 bits, so the 2 bits will be added to it. In this case, this is 2 to the power 0, 2 to the power 1, this is 2 to the power 2, 2 cube, 2 to the power 4, and this is 2 to the power 5. So the result should be 40. We will check. So A right shift 2. Sorry, I have performed the right shift. A left shift 2. A left shift 2 is 40 because we have shifted 2 bits left side. Now when I perform the right shift to the A, what is the value of A? It is 1 0 1 0. Now I am performing the right shift by 2 bits. Then these 2 bits will be removed. The result is 1 0, which is 2. So if I perform the right shift for the A by 3 bits only, then 1 will be left. The result will be 1. We will check that also. So we are taking A is equal to 10. Now I am performing right shift to A by 3 bits. The result is 1. This is how we perform the bitwise logical AND, bitwise logical OR, bitwise exclusive OR, bitwise left shift, and bitwise right shift.